Hey guys, so in this video I'm going to explain some of the answers for the practice questions that you had to do. Okay, so the first one is calculating the number of atoms. Okay, and for 1.1, how many atoms are in 0.45 mole of iron? Now, it's actually a trick question because it doesn't matter what element it is. Okay, the number of atoms in a mole is fixed, right? 1 mole will have 6.022 times 10 to the power of 23 atoms. So this is very straightforward. 0.45 mole is just 0.45 multiplied by the Avogadro's constant. Okay, in other words, 45% of what you have here. So that will be 2.70 or 7099 times 10 power of 23 atoms. Okay, this is for number 1. So for number 2, yes, it is specific to the iron atom. How many atoms are in 0.45 grams of iron? Okay, so for this we need to check the periodic table. So for iron, Fe, it's 55.933. Okay, so the atomic weight is 55.933 grams per mole. Okay, so before this you have done a question on how many atoms for 1 gram. Okay, so if you're kind of confused on how to calculate, always go back to that. You know how to calculate for 1 gram, so take it from there. Okay, so in this case you have to divide 0.45 grams by the atomic weight, 933 grams per mole. This will give you the answer in mole. So if you want to get the answer in number of atoms, which we have to, just multiply everything by the Avogadro's number. Okay, so the answer will then be 4.845 atoms. Alright, for number 2, you can refer to the example in the slides because we've already solved this. Now let's go to question 3. Write the electron configurations of the elements. So for this, the first step is of course to establish the order, because if you look at A to E, you'll find that the number of electrons in these elements are increasing. Okay, for example, magnesium starts at 12 and then it will go up to, for gold is 79. Okay, so you know that eventually you need to hit the larger what do you call this, subshells. Alright, so it's worthwhile to just establish this first. Okay, of course you don't have to do all of it. I think this should be more than enough. Okay, so the arrow goes this way, this way. Of course, if you have done this somewhere, maybe in the previous class or something, you don't have to do it again. You can just refer to that. Okay, but I like to repeat this in case you have not fully mastered how to write this. Okay, now that we have the order, you could also just write out a random, just fill it out. Okay, so I'm just going to do that here. 1s, 2s, 2p, 3s, 3p, 4s. Okay, I'm going to stop here, but you can of course continue. Okay, and how it's filled, if it's full, it should go for s is 2, 2, p is 6, s is 2, 6, 2, 10, 6, 2. Okay, and this is 10, 10, 10. Alright, so this should be our base. Of course, you can have longer so that you know what goes after this. Because obviously you need 79. This is only 36, 38. So if it's more, if anything is more than 38, you have to continue this. Alright, so basically this is how you solve. And for magnesium is 12, so we stop at 3s2. Okay, so magnesium 1s2, 2s2, 2p6, 3s2. That's it. Okay, please solve for the rest. Now for number 4, write the configuration for the iron atom and the ions. Okay, the Fe2 plus and Fe3 plus ions by using conventional SPDF notation. Okay, so to figure out the ions, the 2 plus and 3 plus ions more easily, we need to first do for the atom. Fe atom is neutral, it's not charged, therefore it has 26 electrons. Okay, you can refer to this periodic table. 26 for the neutral atom. 26 will be, this is 10, 20, 6 from here. This is 30, right? So 6 from 3d10. So it will be for Fe 1s2, 2s2, 2p6, and then 3s2, 3p6, 4s2, that's 20, and then 3d6 to get 26. So this is for Fe. Now, what happens to the Fe2 plus ion? It means that the Fe atom has donated 2 electrons. Okay, when it donates electrons, it will be positive, right? This is discussed in the previous class. Okay, when it donates electrons, it will become positive. So the charge depends on how many electrons it donates. So from 26, it donates 2. So it will be left with 24. Therefore, the ion will have the same 20 electron configuration, but for 3d6 it will be 3d4 because it will have 2 electrons less. Okay, because it has donated the electrons. That's it. So for Fe3 plus is the same thing. It will have the same configuration until here, and then this will be 3d3 because it has less 3 electrons. Okay, that makes it a 3 plus ion. Okay, so that's it for this video. Please complete all if you haven't, even though the deadline is before 2. Okay, but I will consider your submission, not the answers but only the submission, after 2 p.m. For those who have submitted, very good.